Saber Astronautics is developing the next generation of mission control. So we're modernizing space operations for the general public. Spacecraft called CubeSats, really small satellites, have this problem where when they die, they become junk. And they sit up in space and orbit for many, many years, and they could become very hazardous to any other spacecraft that have much higher dollar value. So the challenge is, how do we get this thing back down to Earth? Mostly the approach these days in reducing space junk is regulation. So when you engineer a spacecraft, you have to design it so you minimize the amount of junk that gets shot off the spacecraft at the end. What we've invented is a tool called the DragN. So it's a electrodynamic tether, which sits at the bottom of your spacecraft and unrolls like a yo-yo. Tethers are very difficult to manufacture and difficult to unroll. You get snagged a lot, and then you just got another piece of space junk up there. So we've done massive amounts of testing to make sure that that's going to unroll properly when we're up there. You've got a pitcher, you've got a catcher, and you've got a safety. The safety job is to make sure I don't fly away. All right, you've got 30 seconds in 2Gs where we're all lying down, and when the ZeroG portion happens, we got 30 seconds. Gently sit up, ZeroG, ZeroG. And then we pull, and then release, and off it goes. And in ZeroG, it releases very smoothly and unrolls completely.
Release, release. That was excellent.
The tether that it unrolls is a special material called Aracon, which is as conductive as copper, but it's got the properties of a textile as well, so you could weave it, right? So it makes a really strong cord that's also conductive. So it flies through the plasma in the Earth's orbit, and the magnetic fields in the plasma go across the wire, which means a current goes this way, and another force called the Lorentz force goes this way. And the force going this way drags the satellite back down to Earth in a very short time.